Good afternoon. By way of introduction, my name is Shawn Bice. The databases here at Amazon work with a great group of Amazonians who are coming in every day to build the database services you know and love, and appreciate having an hour together to talk about these things. So we've got, we've worked pretty hard. We have the agenda has three parts. In the very beginning, we'll talk a little bit about sort of trends in the industry, access patterns, etc. The second part is we'll talk about some of our customers and how they've reasoned their workload and use case to pick the right tool for the right job. And then the third part of the agenda will kind of zoom into a few announcements, key announcements from this morning, take a closer look, and then get after some demos. Does that sound okay? All right. So just real quick, how many people? This is your first reInvent by raise of hands. Oh my God. Oh, that's awesome. How many people here have been, by raise of hand been to 8 reInvents? A few of us. How about 5? Okay. How about 3? Awesome. Okay. That's amazing. So let me ask this. How many of you use RDS? Just by raise of hand. DynamoDB, Neptune, ElastiCache. Cool. Ledger database. Okay. All right. It gives me a good purview. I'm telling you, I'm really surprised. I've never seen this many first-year attendees. So welcome. We really appreciate it. So let me start talking about one of the most fundamental questions that I get from customers. And usually when I sit down with customers like yourselves, or a CIO, or a chief data officer, or a CTO, in reality, what our conversation truly looks like, if I had you with me, I usually, the CIO will pull me to the side and say, hey, look, we're an enterprise. We've been in business for a long time. I have legacy to deal with. I have monolithic applications that have been here for a while. I'm trying to modernize these things, and I'm trying to bring in more talent. I have folks here of 15, 20 years on these systems. I'm trying to bring in new talent. Yeah. We'll give this another try. And then ultimately where they pause is they're like, one of the things that we're trying to do is just sort of think through this database strategy, because the world is so different. And oftentimes, how many people have been in the industry for more than 10 years? Okay, most of us. So most of us probably grew up building applications probably against a relational database sometime in our life. And we're pretty used to this notion of tabular data models. It's just, if you've been in it for a long time, you've been in it for a long time. But when you really when you kind of think about sort of the way things were, back in the day, it was about a small number of providers that would give you a set of choices. They were usually relational systems, and that was it. And off you'd go, you'd start building. But app builders today are not really building these monoliths anymore. They're really looking towards these purpose-built systems, or taking a big app, breaking it into smaller parts, picking the right tool for the right job. But one of the questions that almost always comes up is, why are there so many databases in the industry today? And one way to answer it is over the page here. I always kind of walk people through memory lane for just a brief moment. And if you remember back in the 60s, it was about mainframe, and then in the 80s, this client-server thing comes along, and this is the first time we sort of separate app logic from a database. And that doesn't mean there isn't any app logic in the database, but we got these two things. The client is a bit of a monolith. The database is a bit of a monolith, if we remember those days. In the 90s, the internet arrives, and then, if you remember, the 3-tier architectural pattern just emerges. And it's exciting because we get to make the client thinner, We end up sort of distributing the application tier. And I always pause here and remind us, especially those of us been in the industry for a while, for many years, while the distribution of these pieces was at a client layer and the application tier layer, we were almost always building against a single database for almost 3 decades when you think about it. And sometimes this is maybe why people today, especially folks that have been in the industry for a while, sometimes think, well, if I'm going to build an application, the right answer is just a single database. But for those of us that have, sort of gotten into this new era of the cloud and we're dealing with these new database systems, the whole idea of this general storage, general compute to satisfy all access patterns, I don't know that that's real. These systems today are way more specialized. Well, why is that? And I would argue it's because of the microservice architecture. And it's not that microservices just arrived a few days ago. It's actually been around for a while, but why are microservices so popular nowadays? Well, I would argue this. If you remember, when we would have to stand up different systems and buy different hardware and get more people to manage these things and understand them, microservices in a self-managed world, that's complicated and expensive. But if you fast forward to what's today, what is today? What does a developer have access to today? Well, a developer today has access to this simple, fully managed API with HA that's usually built in, some sort of performance tuning, auto scaling, and all that stuff underneath is no more. And this is why I think developers are building faster than they ever have before. They're experimenting faster than they ever have before because they don't have to go through all the stuff we used to go through years and years and years ago. If you remember the day of, like, let's talk about the disk and how things are striped and how's this thing going to move to the architecture. Remember those whiteboard conversations? I meet developers, they don't even think about that. So in some sense, I think microservices has finally reached the database. And these databases are more specialized than they've ever been before. So if you use that as a backdrop, then the next question that usually pops up is, hey, what's an easy way to think of a data strategy? Now, one way to do that is to go through the list of every database that's available, compare features, it's kind of how things used to be. But another way to do it is to just think about these common database categories. And I'll do this briefly. Relational is a category. And basically, most of us have plenty of experience, so I won't spend a ton of time on this. But when somebody asks me about relational, I always say this. If you don't know all of the questions you're going to ask to your data, but you want to make sure that those responses are strongly consistent, and you want to basically put a constraint all the way down to the data type, relational systems are remarkable for this. They're great. And this is where Aurora fits, RDS fits, so on and so forth. Key value systems are remarkable for workloads like this. If you and I were going to build a rideshare app, I bet you we'd sit around the table and we'd say, hey, well, how many users are we going to have? I'm not really sure, but we could have 10 users, we could have 10,000, or we could have 10 million users around the world with any device accessing this thing. And once somebody gets into a vehicle, that could be the user ID or the key, and then the value could be the GPS coordinate that we record every half second, for example. Key value systems are remarkable for these kind of workloads. Why? Because I could have one item in a table or 1 trillion items, and it performs the same, because these things were designed for scale out from day one. And then we think of document as a category. And in most sense, when I talk to developers, most of them will say this to me. I don't want to be a DBA. I don't need to be a database expert. I'm building the app. I don't want to sit down and predefine any schema. I actually want to create the data model on the fly as a JSON document. And then when I deploy my app, I just want the database storage thing to absorb that, index it, and allow me to query that data. That's in a nutshell what that conversation sounds like. And I kind of always pause here for a moment for those of us, if you remember in 1998 when XML was a thing, what did relational systems do in 98? They would add XML as a data type. Now it's an XML database. Is it? Or did you just add the data type? Probably you just added the data type because not all of your operators actually work against it. So I'd kind of argue what XML was trying to do back then is what document databases do today. In-memory is a category. So if you and I were going to build an online video game, and you got all these first-person games, some competitions going on, most of these people want to know where they are on the leaderboard straight away. You know, could you imagine doing a full table scan trying to show somebody where they are on a leaderboard? Or might you use an in-memory specialized data structure like a sorted set in Redis for that? You know, it's awesome for that kind of use case. Graph, highly connected data. You and I are working at a shoe manufacturer, and we've got professional athletes and people that want to follow them, and we're trying to make recommendations on who else to follow based on your interests. And these graph systems are incredibly awesome. Why? Because they're designed to traverse nodes and edges. Mainstream. Sometimes I'll go to Stack Overflow and search up how to do graph in a relational system. And you'll see example. I've come across 2,000-line SQL script trying to do something in that regard. Then you look at a system like Neptune, you know, what I can do with a handful of lines of code is exactly why these graph databases exist. And then, of course, time series. We announced TimeStream last year. We've been working with a very broad and diverse set of customers to make sure all of this right. But time series data is around us. You know, vibration of a machine, temperature of a machine, a door opening, closing, something being picked out of a bin. But, you know, I've had some folks say, hey, if I have a timestamp in my database, does that make it a time series database? I don't think so. I think that's just a timestamp in a database. What makes a time series database is at its core, the single primary axis of the data model can be one thing and one thing only, which is time. And now I can optimize the whole stack. You know, time series database doesn't do updates. It's inserts, append only. So how I compress it, how I store it, how I access it, very different than other systems. And then, of course, the ledger. And the reality is, it's not that a customer said to us, can you build a ledger database? What they said was, is there a database technology that allows us to prove, like once I write to it, I can never change it, and I can prove that that data has never been changed? And they usually follow it with this. I try to use auditing and access control, but there's still human beings involved, and you know, do you have a database that has those characteristics? And that's what a ledger is all about. For anybody who's a database professional, I always talk about it like this. It's an immutable transaction log with cryptographic verifiability. And that's what this thing is designed for. So with that, the one thing that I would say to everybody here as a first year, our database strategy is really simple. It's always working backwards from what you're asking us to do. And that's reflected on this page. And what you've asked us to do is ensure that we have the best APIs in each of these categories that are fully managed. Full stop. And that's how we're operating. And another set of questions that come along the lines here is what is really top of mind for customers with all of that as a backdrop? There's three things. One, a lot of customers are thinking about move to managed. In other words, I'm self-managing something and I need to move into the cloud and I need that database to be fully managed, so I'm not doing that undifferentiated heavy lifting. What do I mean by that? I'm not sitting around doing backups and monitoring, patching of machines. That's done for me. Second thing that's top of mind is break free. So I've been in the industry long enough. I hear a lot of people say, hey, I've been on this commercial system. I need to move to open source. And for years it was talk. But in reality today, it's very real. I meet customers almost every day that are sharing a story with me on how they move from a commercial system like SQL Server or Oracle Server to open source. But that is a very top of mind thing. And it's not moving one or two workloads. It's about moving full estates. That is the type of discussion. That's the problem that we're trying to help solve. And then number three is new modern apps. You know, hey, I need to modernize and build a new app. And some enterprises think about all three of these things. Startups usually think of one, which is new. But this is the top of mind stuff. So we take a closer look real quick. Move to manage is really sort of a mental model like this. What services are fully managed such as let it be RDS, Aurora, ElastiCache, DocDB. So for example, if I were self-managing Mongo and I wanted to move into a fully managed environment, I could do that with DocumentDB. Or if I'm self-managing a SQL Server and I want to move into a fully managed environment, I could do that with RDS SQL Server. Or if I'm doing something with MySQL or Postgres on premise and I don't want to do undifferentiated heavy lifting, I could move into Aurora. A lot of customers then also think about the tools. So I think we've all seen tools for some time. These tools are smarter than they've ever been before. So the schema conversion tool is a tool that folks depend on now. And that tool will help you point it at, you can point it at a source and point it at a target and will help you do conversions. The reality is these tools can get you like 80, 90% of the way there, and then that last mile, human beings sort of step into the program to sort of help with certain translations. But the goal is to keep making these tools smarter every day. The data migration service is another tool that many customers depend on. What does that thing do? Well, if I have a source, I have a target, and keep that primary source online while I'm moving data to this new place. And then, of course, these programs. And I bring programs up because not every customer, I've been stopped, a lot of customers like, oh, I actually didn't know you had that program. So I wanted to list it here. So it's the Migration Acceleration Program, which has all sorts of benefits and credits, professional services that come with it. So if you're thinking, hey, I'm in the midst, I need to do a large-scale migration, think about that Migration Acceleration Program. There's plenty of professional services that can help you, and of course, certified partners that have experience. On this break free from commercial, the services that many think about out of the gate is taking something like SQL Server or Oracle, and then moving into Aurora. Or it could be a NetTeasa into Redshift. And I'll say this, for the first time in my career, when I meet people, man, they are really bothered more than I've ever seen before in terms of somebody changing licensing terms on something they already bought. SQL Server is a good example of this, where I bought this thing, I had the ability to take it and run it wherever I wanted, and all of a sudden the license changes on me and I can't. And that sort of thing, that's just another thing that agitates a lot of customers. So my favorite story here, I can't name this customer, but I was with this customer, they said, hey, we've got this really important app. It's how our flight attendants and our pilots bid for time. This thing is like mission critical. But we got a story for you. You know, we basically, this thing ran on Oracle Exadata in 3 weeks. 3 weeks, we moved it over to Aurora Postgres. Unbelievable story. They used the tools, they used the programs, they got it done. And one of the things that I found with a lot of customers is when you have professionals like yourselves that know these systems and can help move things forward, they get done quickly. And then, of course, the one additional program that I wanted to point out here is DB Freedom. And DB Freedom just has a bunch of extra benefits for you to sort of reduce your risk and accelerate those migrations. And then, of course, when we think about these new modern applications, it's really sort of reasoning against these new requirements. You know, I don't meet too many builders that are building monolithic anything anymore. It is all about these modular services and trying to stitch them together because they face these new requirements. You know, you and I could be sitting there saying, hey, how many users do we really need to deal with? And, you know, back in the day, it was pretty well known. It could be 1,000, 10,000 people on a corporate network. Now my users can literally be anywhere in the world. And then when those users are trying to connect to our services, they expect those services to run extremely fast. So now my latencies that I think about are millisecond, microsecond latencies. These folks can be connected from any device, and off you go. And when you look at the architectural pattern of most of the apps that are doing quite well in the cloud, they all follow this. They're highly distributed, loosely coupled. They follow that microservice pattern. So with that, let me bring up Joe and Tobias to share a few customer stories of how these customers have reasoned against these categories with given workloads. Gents?
Thanks, Shawn.
All right, thank you.
Thanks, Shawn. All right, so let's talk about some of these workloads, some of these access patterns. Let's start with how Lyft uses DynamoDB. So many of you have used Lyft before, a ride-hailing application. And if you're thinking about an engineer and you put yourself in the shoes of an engineer building that application, you have to think about, I need to build this for not thousands of users, millions of users. And I need the performance to be able to scale, whether I have 10 users using the system or 10 million users using the system. And if you think about what Lyft uses DynamoDB for, they use it for the individual storing of GPS locations particular to your ride. Right? That access pattern, that use case lends really well to key value patterns, right? Because you're doing gets and puts for an individual rider based on a known key. And if you have that access pattern, and you can use a key value database, you can store and you can scale that database horizontally, virtually unlimited, and still have that consistent single-digit millisecond performance regardless of the scale of the riders that you have. And it's a really great use case for that database.
Cool. So let's take a look at relational example here. So the great thing with DynamoDB that Joe mentioned is that you can handle basically any scale, but it does rely on you creating exactly the keys that you need in order to handle your access pattern. So it relies on a very well-known set of queries. Whereas if you take an example like ZipRecruiter, so they run an online employment marketplace connecting something like 1 million businesses with 100 million job seekers. And they need to be able to have a rich query experience over this data set because you don't know exactly what a certain employer or job seeker is going to search for. So they need a system that's optimized for a varying set of queries that you can evolve over time. And that's a great example of why ZipRecruiter built on Aurora MySQL. Because with MySQL, they can query anything, they can query their data model in basically the way that their user sets it up. You may need to optimize some things, but you don't have to change the app in order to support new sets of queries. Sometimes you maybe need to create an index or something like this. So this is a great example where relational databases shine. And in order to handle the scale, given that the system like this is extremely read-heavy, typically, and for sure in ZipRecruiter's case, they just create the number of Aurora MySQL read replicas that they need to support their workload, where we support up to 15 read replicas per writer instance.
All right, Tobias. But what if you don't know what your schema is going to be up front?
Ah!
Yeah, imagine that.
That's terrible.
Imagine you don't know everything. You don't know all the features that you're going to develop, the feedback that you're going to get from customers, and how that schema is going to evolve before you build your application. That's where a document database comes in. As a flexible schema that allows you to iterate quickly by using a document, you can use the same document you're storing in your application and then just write it down to the database. So let's take Liberty Mutual as an example. Liberty Mutual sells insurance policies online to a very wide variety of customers. And they use JSON to be able to store information about their customers, their policies, the assets they're insuring, the driver history that they use. And that evolves over time based on what the actions of their customers are as they purchase and use different things on the website, but also based on what happens in their personal life and driving history. And they need a flexible data model for that, right? And it really helps them to be able to iterate fast and deliver new features without having to go in and change schema in the database. The also benefit, similar to a relational database, is that I can still look, I can grab a policy for an individual customer, but I have the ability to query across my documents, right? I can do groups, I can do sums, mins, max, averages, and I can ask questions like, hey, how many people bought a policy in New York yesterday that were greater than the age of 25 years old? Or how many people had this particular discount over the last year, right? I have the ability and the capabilities with a query processor to be able to go and answer an unbounded set of questions. Now, a question I get personally a lot is, when should I use DynamoDB and when should I use DocumentDB? And I think the use cases here really highlight those. Lyft is a great example. I have a known access pattern and I need basically boundless scale. If you have that access pattern which is locked in, DynamoDB is a fantastic choice and it excels there. If you're like Liberty Mutual and you say, hey, I know my data model is going to evolve, but I don't know all the questions I'm going to ask of my data when I start developing my application. Those things are going to evolve over time. That's where a document database can really help.
Cool, so let's take a look at another category, which is the in-memory category. And in-memory is one of these that can throw you off a little bit. Memory, I heard other software uses memory. Probably these relational thingies and dynamo thingies and document thingies also use memory. The key difference here with in-memory databases like Amazon ElastiCache is that they're optimized for latency over durability, meaning that both your reads and writes will get microsecond latency. So you will use this when you need something that's super, super fast. Now, a great example is a company like Ubisoft. So they develop interactive games such as Assassin's Creed and Let's Dance. And the gaming example is a great one because you can imagine if you play a game, you don't want, you're playing Assassin's Creed and then you're hitting something, and then all of a sudden it says, no, you missed, but you saw that the person you hit was just there because the latency in the database as you share between players is too high. So you need very, very low latency, and that's really the key to this access pattern. Now, take Redis as an example. So we have Amazon ElastiCache for Redis, which Ubisoft uses. It has a bunch of nifty data structures that you can use that are very, very practical for lots of these use cases. A sorted set, like Shawn mentioned, is one of them. So with a sorted set, you can very easily create an always up-to-date leaderboard. Now, there might be something wrong in the leaderboard in Redis sorted set, because whenever I play this Let's Dance thingy, it always has me in the last place rather than the first place, which it obviously should have.
Hard to follow that, Tobias. Thank you. Nice mental picture. All right, so graph databases. So sometimes folks ask and say, hey, relational databases have relations. Graph databases talk about querying relations between entities. How are those two things different? Well, you think about a graph database, is the data model is really two things. You have these vertexes, which are the circles. You can think of those things as nouns, right? Those are people or a skill or a sport. And they have another construct called an edge. And edges are directional, and they connect vertexes together. What's really unique about graph databases is you can actually query on those connections, right? That's different than a primary foreign key relationship in a relational database. And these databases are really good for use cases to be able to answer questions like, hey, who are friends of my friends, right? That's traversing a social graph. Or I'm looking at a book online, who who other people have purchased this book, what other books have they purchased? And let's rank those by how good those books are by other customer reviews. So let's take Nike as an example here. Nike wanted to build a social graph to be able to connect their customers, right, with their athletes. And the solution that Nike started off on, they could scale to the orders of thousands of connections within their graph database. Now you think about Nike, right, and you have how large of a company that is, and then the athletes that they have, Cristiano Ronaldo, Serena Williams, LeBron James, they needed a database that could scale to millions of connections within a graph, right? That's why they chose Amazon Neptune, right? Because it's very efficient for being able to have those access patterns of saying, hey, who else is interested in running marathons in this particular city, or what are the other people that follow LeBron James? And that's what graph databases are optimized to be able to answer.
So let's take a look at the last category here, ledger databases. So a ledger or a journal, they've been around for a while, probably thousands and thousands of years. People have been keeping track of events over time. And typically what's important with a journal is that you know that no one has gone into the journal and adjusted something, either changed a record or maybe inserted a record in between. And traditionally, databases have been used for lots of these things, right, to keep track of journals. So an example would be something like a banking system, bank transactions, or maybe records in a hospital journaling system. Now, if you use a traditional database for this, how do you make sure that no one comes in and pokes around with your records? So in a journal that's written on paper, it's pretty easy to see if someone has been there and poked around. But in a database, who knows? So what do we do to protect ourselves? Well, we rely on access control lists to make sure that only specific people have access. And we rely generally on auditing. Auditing is another database. So we then just rely on another database to keep track of the first database. And this comes down to, at the end of the day, people. So are you sure that nothing happened? And how do you verify this? And so let's take Klarna Bank as an example. It's a Swedish company that's building out a banking platform, and they need to be able to verify that the bank transactions haven't been altered. And this is where QLDB comes in, which is our ledger database. And the key with QLDB is that you can use cryptographic verification to know that nothing has been changed in your journal. You don't have to trust a third party because it's based on SHA-256 hashes. So as long as you can verify the hash, which we allow you to do through the API, you can see that nothing has changed. But you still get the performance from a database. So it's perfect for things where you need to verify that a set of events haven't been altered. So again, bank transactions is a great example, journaling for a hospital. But the third party you trust in this case isn't a human anymore. You trust in the hash key. So they use the hash to verify that nothing was altered.
All right, so when we talk to customers and we talk about purpose-built databases, it's really about being pragmatic about working backwards from your use case. This doesn't mean you have to go have 9 different databases in an application. It means looking at your access patterns and saying, hey, does this make the most sense? Is this gonna scale? Is this, am I using the database the right way? And is this gonna be a good long-term solution for me? I think Fender is a really great example. We're seeing a very large trend of customers saying, hey, I'm going to take, I have this old guard database, and that was the tool I had at the time. That was the only thing I had at my disposal, and I built an app on it. And they're taking this time, this inflection point as they're moving to the cloud to really look at the access patterns and how they're using that application, or that database, and saying, is this the right tool for the job? And we see many folks teasing apart that monolithic database and then saying, hey, you know what? This access pattern or this particular use case actually lends itself really well to DynamoDB. This one, I'm storing a bunch of blob data in a relational database. Maybe I can save some money and store this on S3 instead. That might be a better choice. And for some of these use cases, right, ElastiCache for Redis would actually be better. And Fender, and we see this in spades of customers coming and saying, you know what, by doing this, teasing apart the monolith, not only did we get off this license thing we didn't want to have, but we were able to reduce costs by 20% and increase performance by 50%. And then it sets them up for the future to be able to scale. And we love when we see customers be able to tell us that.
All right. So thank you. So I hope a lot of these, thank you, gents. I appreciate it. So last year, after this talk, a number of customers said, hey, share some more stories up there. And that was kind of the spirit of what we wanted to do, is just so you could sort of put yourself in that seat and see how these folks reason things. So speaking of categories, let's take a closer look at what Andy announced this morning in the keynote. So we have a number of customers. I meet a number of customers. They've had Cassandra. They self-manage it on premise. They run it in EC2. And over the years, in particularly the last year, a lot of customers shared these problems, and they've basically said this. Managing these clusters are really difficult. Most folks that I bump into, it's not a 5-10 node cluster. It's order of hundreds of nodes. And they'll talk about, hey, we have dedicated teams that just run these clusters. Then when you get into some more detail, they'll tell you things like, hey, we provision this cluster for max capacity all the time because it's too hard to scale it up, down, or in or out. So we just kind of leave it fully provisioned, regardless if we're using it or not. I've had another customer share a story with me. And the person said, hey, we run on version old because we tried to upgrade to this latest version. It interrupted a node, and it almost blew out my cluster. So those are the problems that we hear from folks. So we're really excited for this announcement about the Amazon Managed Apache Cassandra service. And what's exciting about this is it's a highly available, scalable, fully managed service for Cassandra workloads, which means you can bring your Cassandra application code to this service using your Apache 2.0 tools and drivers that you use today to connect to it. And the real beautiful thing here is it's serverless. So there are no servers to manage in this environment at all. If I translate it to all you that rose your hand earlier about Dynamo, you're used to how a system like that scales. There's no servers to manage there. And an Amazon customer will say, like, hey, can you make Cassandra kind of scale like Dynamo does? And that way I don't even have to think about this stuff. It's just as the workload puts pressure on the system, it will scale for it. And that's exactly what the team has built. So there's no better way to see this than a demonstration. So Joe, can you join me again and we'll do a quick demo here.
All right, so what I've done is the hard part. I set up a self-managed Cassandra cluster on EC2. And what I'm going to show you quickly is how to get that data into Amazon Managed Cassandra Service, or MCS. So I am going to log into my local instance within Cassandra here in my local machine. And I have a few rows of data, some information about some city statistics. And while I'm here, I'm going to copy this data down to my EC2 instance. So I'm going to bounce over to the AWS console for MCS. And I'm going to go in and I'm going to create a table. And I'm going to do that. One of the really cool things that they added for MCS is an in-browser SQL editor, or CQL, not SQL, CQL. And I can run this command and I can create a table. Right, so let's go in. Right, and I can run this command. And I can see I don't have any data in there yet. What I want you to know is on that left-hand side, you don't see the words instances or clusters over there, right? Just tables in key spaces. And that's the beauty of the serverless offering. Okay, so we're going to come back here. This is my self-managed EC2 instance. I'm going to exit out of there, and I'm going to use the CQL shell to then now connect to the table I just created and copy that data up there. So let me log in, and I'm going to copy that same data I just wrote to the local file system here. And then let's bounce back over to our handy CQL editor, run our query again. Now I have my data in MCS from my self-managed Cassandra cluster. So thank you.
All right, thank you. Let's switch this back. All right. So that's how easy things should be. And the real benefit here, again, is you can take that Cassandra application code that you have, and these are the Apache 2.0 licensed drivers and tools. And then the programming surface that we support is Cassandra 3.11. So it's, we're excited for the preview. Everyone in this room, if you're a Cassandra user, you can get into this preview today, and off you go. So that sort of fills out a new category for us. So now let's switch gears and talk about some of the work that we're doing that cross-cuts these different services. And if you think about sort of this idea, over the page is a simple architecture. We drew some of these pictures as if we were on a whiteboard together. But the idea is, imagine if you have you're tracking shipments in one system, you have a product catalog in Aurora, you might have some user personalization in document DB, and so on and so forth. Maybe your order processing is happening in ElastiCache. But that's pretty representative of what a microservice architecture looks like. Now, some folks that see these architectural drawings, that's too many moving parts. But I always remind folks, people are not building monolithic apps like they did in the 80s and 90s. This is pretty standard of what things look like. Why? Minimize blast radius. One thing breaks, I don't take the whole system down. Right? It's about how I operate this environment, how I scale it. But if you think about the operational aspect of this environment, imagine when the phone call comes in that says, hey, the system's running slow. Do I log into each and every one of these systems individually to take a look, or is there a way to query across these systems to get some insight? So that's why we were really excited for the announcement for Athena Federated Query. An Athena Federated Query allows you to run a SQL query on relational, non-relational, object, custom data sources, etc. It's really, really straightforward to use. There's a number of connectors that are available. And another great part is you can actually build your own connectors. And where I find this one super useful is I'll bump into a CIO who has legacy, years and years of legacy. And when they see this, they're like, wow, this is a great way for me to connect into some of these different systems. So the spirit of Athena Federated Query is not to replace these native APIs, but think of it as a complement. And Joe, can you join me again? No better way than to just see a quick demonstration of this from an operator's point of view.
All right. So let's put ourselves in the shoes of a decision support engineer. It's the holiday seasons, and customers start calling us and saying, hey, some of our orders are stuck. How do we, what's going on in the system? And as a decision support engineer, you have to say, given the architecture that Shawn showed, that's a lot of different places to start poking around to understand what's going on in the system. Wouldn't it be great if you could just run some really simple diagnostic queries over the top of these different purpose-built data stores to be able to answer and do some quick diagnostics? So I'm using Athena Federated Query, and I have a query here, and I'm going to go through this, right? I'm going to go first to my CloudWatch logs, right? And I'm going to do some regex expressions there to look for anything in the error messages that have anything to do with orders. And Athena Federated Query is not just databases, right? It's also CloudWatch. I'm going to go to Redis, and I'm going to query what's in my customer orders. I'm going to query the EC2 instance workers that I'm using. I'm going to take my customer and order information from DocumentDB. I'm going to take my shipments from DynamoDB, and I'm going to grab my payments from HBase. And I'm going to select the fields that I want from each one of those and join all of those different result sets together. And my query is finished already. So now I have one single result set queried across all of those different databases joined together. Right? And I can start to look through this data and notice that, hey, my order processing log, I'm starting to see errors and warnings, and I can go back and say, hey, you know what, this EC2 processor has, it's correlated to those errors and warnings. Maybe I'll begin my investigation there, take that EC2 instance out of the fleet, and then start my investigation. So just a really quick example of being able to query over the top of multiple different data stores.
Good job. You're doing good at these demos. Thank you.
Thank you.
All right. So again, the spirit of this is to give you some teasers, and then I'll show you a list of sessions that will go into plenty more details. So another thing, another cross-cutting thing is machine learning. And how many people here are experimenting with machine learning technology just by raise of hands? So a lot of us. For those that have raised your hands, you'll probably be familiar with these problems. For those that didn't raise your hand, this is generally the type of problems we hear. Some folks will say, hey, you don't have machine learning without data. Data truly is the gold mine that feeds these algorithms, and what comes out of it can be predictions or fraud detection or sentiment analysis, etc. However, one of the challenges is if you've been writing in SQL for some time, all of a sudden you want to go do something like sentiment analysis against, let's say, a product recommendation table or a product comments table. You start to think to yourself, okay, now what model do I pick, and how do I train that model, and how do I interact with that service? And then what kind of application code do I have to change to shape the data, to send it over to the service? Then when the data comes back, how do I change the shape to stick it back in my application? And it can be this very complicated workflow. But we're really excited to announce, for example, the Aurora integration with machine learning, which really, really, really simplifies this. And you've got deeper integration with things like SageMaker and Amazon Comprehend for sentiment analysis. And, I think this is where things begin. It's not where they end. But there's nothing better than a demonstration to show you just how easy it is for a SQL developer to interact with a machine learning service like Comprehend. Joe?
Let's do one more.
Last one.
All right. So it's the holiday season, And yes, I do want to connect. It's a holiday season, and we have some categories, some products, and some reviews. And I really want to know how my business is doing. So as Shawn said, wouldn't it be great if I could get sentiment analysis on those reviews natively within the database that I'm already using? Shouldn't it just be as simple as calling a function? Let me show you how easy this is to do. Right? So same query, same select query from reviews, but I'm going to pass that review column to a function that goes out to comprehend. And the beauty of this is that it returns the sentiment for those reviews, right, both the sentiment and then the confidence, right back into my result set that I'm used to using on SQL. And the power of this is now as a developer, right, I can now take this and say, hey, if I want to, I can wield the full power of SQL on it, so I can say like, hey, you know, for category, I want to do a count of sentiment, right, and then I want to do a group by, order by, we'll do count. Ooh. Oh yes, Postgres, semicolon, right? And then I'm able to see now, like, okay, well, yeah.
Hey, you
Now
know
I'll
we
be able
have
to see
this
now.
thing called copy-paste.
Oh, no, you got to do the live demo. It makes it much more fun and exciting with these moments. But now I can see the sentiment. Now I can go in and I can start filtering by, I just want to look at the negative scores across categories. And it's really cool. Now I can use the full power of SQL. If data changes in my table, I just run the function again. I don't have to take the data out of the database.
Yeah, thanks a bunch, man. I
Appreciate
really
it.
appreciate
You
it.
bet.
So, you know, that's really how integration should be. So when you hear things like, you don't have to go off and learn this new thing, you can use tools that you know, in this case SQL, it's a great bar for integration. Now here's one thing that's not in the slide that I'd point out. We're not running machine learning on that database instance. That function called, think of ML as part of my microservice architecture, called comprehend as an API. So if I have a low latent sensitive application that's running on my database, I have a lot of customers say, man, I don't want to put anything else on this database. I can't afford to. That is a great example of that database calling out to comprehend and using the full power of what it can provide. And at the same time, you don't have to go learn a bunch of new things. It's relatively straightforward. So with that, you know, the thing to really underscore here is that building these purpose-built systems takes time and energy. It is not something that one team can just do. It requires different teams with different expertise. Why? Because you're building different storage systems. You're building different computation layers. And this is what our customers want, and this is what we are committed to do. And you know, I often am asked how many more categories are to come. The reality is, I don't really know. I don't know that it's another 5, 6, 7, or 8. I think this is a pretty good group. But our strategy is relatively straightforward, and is to have those APIs fully managed in each category. And we'd like to believe, you know, over the page are the set of services that we provide, from Relational all the way down to the managed Cassandra. And then, of course, you know, we know that we're delivering the most complete family of purpose-built databases so you can build the most demanding apps. And that is our commitment to you. So these are a few related breakouts if you want to take a picture. So if there's something in here and you thought, oh gosh, I wish they would have talked a little bit more about this or that, we try to fit so much into this 60-minute section. But these are breakouts that you might try to get to for more detail on what's interesting for you. Of course, you can go to training. Oh, yep, yeah, I'll go back. Grab a picture. You good? Okay. Then, of course, there's training. And I got this fun announcement, aside from saying thank you, because I really appreciate spending the time. So if you have one of these 2 vouchers on your chair, I think these things are called vouchers, they're swag vouchers. You take it to the swag booth, and they'll give you one of those AWS Databases t-shirts that those guys had on. And if you don't have one of these, the real reason is we didn't print enough. a whole bunch of you showed up, but we have something like 2,000 t-shirts. So just go to the data booth, tell them you were at this session, and I suppose if you want to hook your buddy up, do the same thing, but go to the data booth and you'll get t-shirts and socks to go along with the deal. So with that, I appreciate your time. If anybody has more questions, please come to the front of the stage, and we've got a bunch of people up here to answer questions. Thank you.